In this, it is asked to determine whether the system described below is causal and stable. Again, we need to check for whether the system is causal and stable both. So given is 1 plus 2 z inverse divided by 1 plus 14 by 8 z inverse plus 49 by 64 z inverse square. So if you find out the roots for this one, you will get z plus 7 by 8 square. Okay, that means there are two poles at z is equal to minus 7 by 8. That is depicted in the below figure. And you know that 7 by 8 is always lesser than 1. 7 by 8 is lesser than 1. Both the poles, then what you can say, minus 7 by 8. Let me draw it over here. So for this second problem, what we get is z is equal to minus 7 by 8 and z is equal to minus 7 by 8. Two poles are there at minus 7 by 8. Minus 7 by 8 is obviously lesser than minus 1. Our unit circle will be like this. So this is 1 means we get minus 7 by 8 here. There are two poles, minus 7 by 8. Okay, so it is obviously inside the unit circle. Okay, and what you can say, all the poles are inside the unit circle, and we can draw ROC including unit circle. This is what required to show that something is stable as well as causal. It has to be outside outermost pole. So outermost pole is minus 7 by 8 and it should include unit circle. So that is what we have done. So because of this, we can call the given system as a given system is both causal and stable. Okay, that is what I have written here. Since all the poles are lying inside the unit circle in the z plane, the system is both causal and stable. Okay, so all the poles means z is equal to minus 7 by 8 and 7 by 8 because here there is a square. So we need to equate z to 7 by 8 is equal to 0. So you will get z is equal to minus 7 by 8. Okay, so this is the process to know whether the system is both causal and stable. Next problem.